All right, everybody. Today we are looking at solving equations part 2. So remember last week we talked about how we need to learn a process to solve for the value of x because we never know, how many steps we might encounter. And so guess and check just really isn't going to be something we want to rely on. It's going to be too time consuming. So we talked about needing to find a process. Today we're going to look at taking that process we started working on last week and building on it. So your directions are the same. Solve for the variable just being the letter. We're trying to get an answer that is just like x equals a number. Right? But because we do have, in this case, like number 1, we have variables on both sides. So we're going to have to do things a little differently this time so that we can get that variable by itself. So looking at the first one, we told y'all anytime you see those parentheses with a number out in front, distribute. So this isn't going to be any different. We're going to multiply through by that number outside the parentheses, which is a 2. And that's going to give us 2x plus 2 when we multiply 2 times 1. That's going to be equal to this situation here where we have just bring down what we began with, so 2x plus 7. Now, if I told you, okay, let's get our x's on one side of the equation and our constants on the other. In this first example, getting our x's together, a lot of times when I ask y'all what side do you want the x's to be on, y'all like to have x equals a number answers. So I'm going to say let's move our x's to the left. So if we wanted to take this 2x term and move it across the equal to sign, we would need to make it go to 0. And so to make it go to 0, I would subtract it on both sides. Now this is a special case and we're kind of bringing it up right out of the gate here, right off the bat. Our 2x terms cancel on the left, or the right rather. But when you look at the left, 2x minus 2x, that cancels too. And so if we bring down what's left on both sides, we get 2 equals 7. Well, that's not a true statement. So this is an example of no solution. Whenever your x terms just cancel out completely, which will happen from time to time, then that just means that there's no way to make this equation balance. So no solution for our first one. Now for our next one, we have 6x plus 3 minus 8x plus 13 equals 5. So whenever you see multiple x terms on one side, we need to combine like terms first. Remember how we would mark our like terms when we simplified? So just something like that for the x's and then maybe a double underline for our constants. Grouping those, 6x minus 8x gives us a minus 2x. And then putting together our constants gives us plus 16, 3 plus 13. And that's equal to 5 because we haven't done anything on the right side yet. Now this is just like our equations from last week. We're trying to get x alone. So start with anything added or subtracted and let's use our opposite operations. So plus 16, the opposite of adding 16 would be to subtract it. That's good because on the left it's going to get rid of that term for me. That's going to go to 0. And then on the right, 5 minus 16 is a negative 11. And so then remember here, when you have just a number in front of x, that's multiplying. That number, the coefficient times the variable. So the opposite of multiplying is to divide. Take the negative sign with you because we want a positive x term when we're left. And then when you simplify that, you could leave it as the fraction. Negative over a negative is a positive, or you could change it to its decimal form, really whatever you prefer. Now, number 3, we're back to variables on both sides again, right? So taking a look at that one, we want to ask ourselves, okay, how do we get our variables together on the same side of the equation? So we're going to come back and talk about that with our next video, but I want you to think about we need to move variables on one side of the equation and the constants on the other. So what might that look like?